start today's topic, we need to understand the scenario so that we can easily comprehend, easily digest the new topic that we are starting today. So, you must have seen the video topic there. Uh, that's the topic, Azure Virtual WAN. But before we go and start talking about it, let's understand some scenario so that we could get what exactly we are doing here. So let's suppose we have a multinational corporation which has offices in different regions. It will be more than two, but for the sake of understanding, we are only drawing two regions. Let's suppose this is on-premises office region 1, this is on-premises office region 2, okay, and this is Azure Virtual Network region 1, this is Azure Virtual Network region 2. We should quickly update it, and just for the sake of understanding, we should have one more thing which is called a branch office. Let's suppose we also have a branch office in region 1. We just, this is for the diagram, but we, in reality, for this scenario, there will be a multiple branch offices in every region, but we have a definite space here, limited space here. So we are only picking few things to understand the situation, the scenario, and the problem it creates, and how we can solve those problems through our service, right? This is very important to understand. That's the reason I took this scenario of a multinational corporation which has different offices in different regions, could be Americas, Europe, Asia, that that need secure, low latency connectivity to each other and to Azure hosted applications, right? These are our Azure VNets. We may have other stuff going on as well in our Azure tenant, other applications, but that's not the point of understanding. This is the point. We have Azure virtual networks in region 1, office in region 1, so they are connected to each other, right? And we have office 2 in region 2, so they are connected to each other, right? VNet and VNet 2 may be connected through peering, right? Now this branch office, either there are multiple ways that the enterprise define the topology. Either this branch office is coming through this, like request comes through the main office on premises, usually on premises control if they need to access this. If this VNet resources need to access internet, it might possible that it's going to the on premises first, right? So there are multiple way they design, but the point is it is multinational in different regions, and the need is, ask is, we should have, because it is enterprise running uh, finance related, running revenue related, money related applications, right? So they need secure and low latency connectivity. But the kind of scenario this is, one in America, another one in Asia, right? So the distance and the kind of connectivity we have, it must be VPN, maybe MPLS, right? So it doesn't matter. Usually this branch office is connected through VNet, maybe it's another VPN, or if we also have remote users, then there must be point to site connectivities. The point I'm trying to make here, this kind of huge enterprises, multi-regional uh, environments leads to high latency, right? Leads to high latency and unpredictable performance, and unpredictable performance. This is what, this is the point I'm trying to make by drawing these things in a different region, region 1, region 2. Now, how it's high latency? Because if it is a VPN or point to site VPN, it is public internet based connections. Whether this VNet is going to the office and then going to the internet, this branch office is connecting to office first and then going to the VNet. Then again, it a lot of distance to cover, and this is obviously over the internet if it is site to site, right? This may be MPLS, right? Let's take all the examples, but we cannot have MPLS everywhere, right? So the point is, public internet based connections leads to scenarios like route inefficiencies, right? What I mean by that, well, when branch offices connect to each other or Azure resources through the public internet, data packets take unpredictable paths based on the internet routing algorithms, often leading to suboptimal routes, meaning high latency. You may encounter congestion, internet congestion. Public internet traffic is shared, so by millions of users, causing congestion, packet drops, and delays. Right, so unpredictable performance. Now, let's take an example of this MPLS line. Let's suppose we have MPLS here. Now, the point is MPLS circuit offer dedicated predictable routes but come with a higher cost, right? MPLS will leads to higher cost, uh, especially for the global connections, right? And limited scalability sometimes, because scaling MPLS network to support additional branch offices or new Azure regions is time consuming and costly. Need to go through the dedicated lines to different branches. In some regions, MPLS service may be unavailable, right? So MPLS is not the solution. Now, if it is a cross region communication as well, maybe these are peered to each other, or maybe these are connected to each other and things are going like this. It depends. So, if it is offices in different regions like US and Asia, it suffer from high latency due to the time data takes to travel across the long distances, because it is very far if it is coming like this, right? And this is different region altogether, even if they're going directly, right? Now, legacy systems often route all traffic through centralized on-premises data center. If you have seen the big enterprises which are coming from on-prem to Azure, they've started a little bit of Azure, maybe few branches. So it is true. Legacy systems often route all traffic through centralized on-premises data centers before reaching Azure or other branch offices, adding unnecessary latency. So what exactly is happening if there are multiple branches, if it is also connected to this guy and to the gateway point to site, or maybe other branches connected to each other. So that is leading to a complex network, that leads to complex network management as well. Complex network, hence the complex management as well, leading to the scope for the error and clarity, right? Which means managing a global network with multiple branch offices introduce a lot of issues like independent connections, inconsistent policies, for example, large number of VPN connections. That all leads to complex network management. Because of complex network management, we have independent connections without a centralized solution. Each branch office typically establish its own direct VPN connections to Azure, to other branches, creating uh, mesh or spaghetti like network topology. Inconsistent policies that I was saying, because like security, routing, and connectivity policies may vary different branches, leading to inconsistencies and potential vulnerabilities, or maybe regulations are getting hit, right? So these things will come because of complex network management, and leads to operational overhead as well, because each connection must be monitored, maintained, and troubleshoot individually, increasing the administrative burden. And uh, if we do not have a unified monitoring control, so we will be using distributed tools, which leads to uh, different kind of issues, difficulty in troubleshooting, because some people are skilled on one kind of tool, others are not so well skilled with those tools. So it is like traditional setups often rely on multiple tools for monitoring and management, which operate independently for different sites with different folks, with different teams, different skill sets. So that is another challenge, which again fall under the complex network management. And of course inadequate security as well, because different offices may have implement varying levels of security for their connections, increasing the risk of data breaches or non-compliance with regulations. And sometimes it creates an issue that people who wants to work cannot work, because there's some security policies in some branches and another security policies in another branches, and you're not getting the approval, and somebody saying it cannot be done from here or it has already been done from here. Those kind of unwanted issues also comes. So basically, we have to conclude all the things that we are talking. What are the impact of these problems? Right, we need to understand the impact of these problems. What are we losing? What are we uh, getting out of it? The very first thing is poor user experience. Ultimately, we are working for an excellence or excellent user experience, but we are getting poor user experience. Why? Because applications hosted in Azure or exist between branch offices perform inconsistently, which leads to poor user experience. Second, operational inefficiency. Operational inefficiencies. Why? Because IT teams spend excessive time managing connections, monitoring traffic, and troubleshooting issues. So there goes your time, your team engagement, and everything, and which leads to higher cost as well. Because both in terms of direct cost and indirect cost, direct cost is like if you go with the MPLS circuits, or indirect is like time spent on management and troubleshooting. So your cost will increase for sure if the complexity for the management is high, right? Now it also leads to security risks. Fragmented and inconsistent policies leave the network vulnerable to attacks and compliance violations, right? And it will impact your internal productivity, right? So these are some outcome of doing the work legacy way, I would say, because in modern world we have modern solutions for these kind of problems. So what is that solution? That solution is Azure Virtual WAN, which beautifully addresses these problems, because Azure Virtual WAN routes traffic through global high-speed backbone, bypassing the unpredictable public internet and ensuring low latency. Let me try to find the if I could copy that image and paste it here, it would be nice. Copy, paste, yes. Okay. Now you can relate with this image. This is your virtual WAN. So what and how this is solving the problem? We need to understand this piece. Saying Azure Virtual WAN routes traffic through the global backbone, Microsoft Global High Speed Backbone, because these are all talking inside the Azure. This is Azure, right? So they are utilizing backbone. Even this guy is talking to this, and it all that request will go through the backbone, right? This office go here and quickly goes here and talk to this guy, because it is all happening over the high speed backbone, bypassing the unpredictable public internet and ensuring low latency that we talked. Unpredictable right? It's just hidden behind this image. Now, what you see, if you see closely, you also see now a centralized hub and spoke architecture. This is one hub, this is another hub for region 1, for region 2. This is region 1 hub. As you can see, all are connected to this guy, and they can easily talk to each other through this hub. Number of connections are less, so it simplifies connectivity by creating a central virtual hub in Azure for branch offices, reducing the need for complex mesh VPN setups. And you can centralize unified management, also provide you the unified management. We have already seen a lot of issues and problems because of complex management. So Azure Virtual WAN consolidates network monitoring, routing, and security policies into a single centralized platform, right? And now, since it is unified, single, centralized, it also has integrated security, which is built-in features like Azure Firewall and support for third-party security providers, ensure consistent and robust protection across all branch connections. So by addressing these challenges, Azure Virtual WAN becomes the ideal solution for simplifying, securing, and enhancing the performance of global enterprise network. Right. So let me quickly open one more, or maybe we can just simply summarize here. So if we need to summarize what are the problem that we have seen here, we have seen high latency problem, performance problem, and the complex management, which has multiple small issues, policies related issues, right? And how our virtual WAN is solving this problem by centralized connectivity, Microsoft Global Backbone, unified management, integrated security, and of course, cost efficiency, right? So that's how virtual WAN solving our problem. So uh, if if we have to define what is virtual WAN, it could be easily defined as a networking service that brings many networking, security, and routing functionality together to provide a single operational interface. Some of the main features, as we have already seen here, right? Branch offices connected, even point to site connected. We also have even these can connected to each other through the backbone, firewall, and NVA is also supporting. So that's how we can define it. This was just the introduction so that we can initiate the Azure Virtual WAN from our next video. Till then, take care. Goodbye.